Hello and welcome back to an MGL training session. On this session we're going to be looking at gas pipe sizing in the UK to British Standard 6891. This is a very important British standard that we must follow whenever we are doing or completing this exercise within a domestic dwelling. Please remember, if you do find this video helpful, please remember to drop a like, leave a comment, and even hit that subscribe button and help support the channel. First things first, I must give out this warning. This video, or this training session, is for training only. This will not make you a qualified gas engineer, but it will help you if you are going to be doing your ACS or renewing your ACS. If you are already a qualified gas engineer and you have got your retake coming up soon. Unless you are a qualified gas engineer, you should never take work on gas appliances or pipe work. It is against the law unless you are a qualified competent gas engineer. If you do, however, you will face prosecution. This could lead to a fine or imprisonment or even both. So please be aware, this does not make you a qualified gas engineer. This just gives you an understanding and will help later on if you choose to pursue a career in plumbing or gas engineering and gain the correct qualifications. Objectives. At the end of this session, you should hopefully understand the importance of gas pipe sizing, how elbows and T's affect pipe sizing, the pipe sizing chart from BS 6891. Sorry, I was going to say another one then. They've got so many British standards in my head. You'll be able to draw out the pipe run and understand what you are looking for when doing this, how to calculate pipe sizing, and then at the end of the session you should be able to size for one appliance, and then we'll be looking at sizing for a typical normal standard dwelling. So it's only going to have so many different types of appliances on and so on. Right. Importance to gas pipe sizing. It is important to get the correct gas pipe sizing in place when you are designing for a property for several reasons, but the main ones I'm just going to focus on now. So it is to supply the correct pressure to the appliance. And the reason we do this is it will work at its maximum efficiency, and also it protects you and the appliance and hopefully maintains the manufacturer's warranty. Boilers are very, very fickle. If they do not get the correct, or any gas appliance actually, if they do not get the correct amount of gas going to them, they do not work properly and you will never get the maximum out of them. And which could also lead to poor performance and actually cost you more money as a customer. So it's very important to get this correct. The appliance does not starve another gas appliance. So if you're in a house where you have more than one gas appliance, if you size it all incorrectly, you could light, say, if you've got a boiler and a gas cooker, you've got the gas cooker on, you light the boiler up, the boiler will then pinch the gas from the cooker, and it could cause your cooker to go out and have gas leaks, which could be very dangerous. So you've got to make sure that you do this correctly. If you don't, you could have explosive ignition. So once the boiler stops working, the cooker could relight and cause it to explode, which is not good. Next, you would have poor performance of the appliance. So for those people who have a combination boiler at home, if you've sized it correctly, you will have perfect, and you get good heat from your water. But if you sized it incorrectly, your water will never reach the temperature that you have desired. Over the entire run, or carcass is what we call pipe work in the gas industry, over the entire one, you must not lose more than 1 millibar of pressure over the entire run, from the gas meter to the appliance. Right, this is the important part of sizing a gas for an appliance. Right, how do elbows affect your pipe sizing? Right, so first things first, we're going to look at the fittings. A 90-degree elbow is a normal copper pipe fitting that we use, and it is a very tight bend. The other types of bends that we can have are machine bend or mechanical bends, where we bend them with a pipe bender. This could be a 90-degree or a 45-degree bend, using a manual pipe bender. Right, now how these affect is quite simple. So if we have a look on this little chart here, I'm missing my pointer. Let's get my little pointer going. Right, so 15mm pipe or less. If you have an elbow and it's a 90-degree, you will lose, or it's the equivalent of 0.4 of a meter. Okay, so it's 0.4 of a meter. So it's equivalent of that. If it's a 45-degree, it's 0.15 of a meter. And 90, 0.20. So as you can see, a nice natural mechanical bend where it's a nice long radius bend, it causes less restriction because we're sort of guiding the gas round. But when it's a 90-degree elbow, it's got to hit the bottom of the elbow and then it's got to turn round and change direction. So it's not good. As you can see though, as the pipe size increases, the resistance does increase a little bit. These tables come in later on when we are looking at sizing for the pipework. Right, how do T's affect it? So a T is a three-way pipe where you can have gas either coming in one way and going out the other and coming out the top, or it can be coming in the top and going in different directions. But either way, it is not good. So we need to think about which way the gas is going in. So flow entering from a branch. When we say flow entering from a branch, this is the gas coming down into the T and splitting in two directions. This can cause more problems. The next one is the flow exit into the branch. So this one's nice and straightforward. The gas comes in. When it goes straight ahead, it doesn't affect it anyway. There is no resistance. It's like it's going through a pipe. But as soon as it has to change direction, we now got another problem. Right, okay. When it comes to sizing, one of the key things that you've got to remember is we always take the largest opening on these T's for when we are sizing of how much resistance is going to be in one of these T's. So it doesn't matter whether you're going from, could be, 28 to 22 here and then come up the top here as a 22. We always use the 28. We go for the largest size when it comes to this. Right. Oops. My pointer's coming all over the place again. So if we have a look on here, flow entering the T, so when the gas comes through the top and goes through to the sides, we have quite good resistance. So if we go to 35mm pipe, it's the equivalent of 2 meters of pipe work. So we've got to again bear this in mind when we're sizing. But if we're coming in and then going across and then flowing exiting the T, it's 3 meters. So it's a lot more resistance because the gas sort of has to change direction, doesn't it? It's got nothing to hit. It's got nothing to help guide it. It's got to change direction. So this can cause quite a big resistance. So again, it's very important that we remember this when we are sizing. Now, when it comes to the sizing of gas pipeworks, there are quite a few bits and pieces that we've got to bear in mind. We've got a few more sums to do. We've got to work out the size of pipe that we're going to be using, how many elbows, everything else. We also have to work out how much gas an appliance needs. So as you can see on this lovely little table here, so I was just trying to find my laser pointer, you've got flow in meters cubed an hour. We've also got kilowatts gross, kilowatts net. So depending on what appliance you're looking at, some will give you the readings in net or gross kilowatts, but the more modern boiler will give you that reading in meters cubed. I like using meters cubed more, so I will be showing you how to convert kilowatts into meters cubed. It's just me, I just prefer to use meters cubed. Then we've got our diameters of pipe here, so we've got 8mm, 10mm, 12mm and 15mm. But if you remember from the T's and the elbows charts, 15 and under are classed as one thing, as one loss. Whilst 22, 28 and 35, they have their own resistance. Okay. Let's find the right one. So when it comes to drawing out your system, you've got to first start off with your gas meter. Where is your gas meter? But then you've got to decide what we're going to size. So on this case here, I'm going to have a gas fire. So we've got a nice simple gas fire connected to the meter. Then we've got to trace the pipework. So the pipework comes out from the meter and it's got an elbow on the top and an elbow going down and an elbow coming across into the property. Okay, that's one. So we've followed these elbows and worked it all out. Then it comes across underneath the floor and then comes up into the gas fire. Now, a lot of the time, I know some houses the pipework is hidden. You've got to try and work out where this pipework is. If you are a plumber or a gas engineer, it gets quite easier over time. But to start with, you just roughly work out where it is. Then we've got to say, we've got to pick out a point. So later on when we've got more than one appliances, we've got a starting point, we've got an end point. So we label them all up. So for this one, the gas meter is going to be A and my fire is going to be B because we need this for the tables. Then we measure all the pipe work and we work out what the lengths are. Very simple, very quick and easy to do. Again, you can guesstimate it if you can't find the pipework. You can roughly work out where someone has run the pipes. Then we need to know the kilowattage of the boiler. In this case, or the fire. For this case, the fire is going to be 7 kilowatts net. Very important, remember all the grosses and nets. Make sure that you follow the right one. Right. Now, that was a simple one pipe system. Now we're going to go for a typical system, a standard system. So on this one, we've got another gas meter. We've got a gas fire. We've got a boiler. And then we've got a gas range cooker. So we've got to work out the pipe sizing for this installation. So first things first, trace the pipe work. Work out where all that pipe work goes. I do apologise, yes, I know I'm not the best when it comes to drawing this. I had a little bit of a shaky hand, so they are connected, please bear with me. Alright, so again, now we letter it up, so the meter would be A, but this time we're going to go to the first changing of direction. So the first T is B. So as you can see here, this is the first T, and then we're going to go from the B up to the gas fire. So we're going to make the gas fire C. Then we've got to go from B down this end to this T here. So that one is going to be D. Then we're going to go to the cooker. The cooker will be E. And then the boiler, which will be F. Nice, simple, straightforward. So once we've got it again, all lettered it up, we've got to go around and measure all the pipe work. So we'll get all the pipe work in. We get it all measured. We are laughing. We're on our way to working out the correct gas pipe sizing for this installation, but we're still missing the kilowattage. So I want to whack that in. We've got the fire, which is 6.5 kilowatts. This is just an example. Not all fires are this. They can change. Then we've got the boiler, which is the 32 kilowatt. Again, depending on the size of the property, depends on the size of the kilowatts of the boiler. And cooker, I put down here as 18 kilowatts. Cookers, again, can be any size of kilowatts. You've just got to check the back where the data badge is and it'll tell you what the kilowattage is. All the manufacturer's instructions. Then we've got the first table. Right, when it comes to working these out, as I say, I like certain parts to make it a little bit easier. So I've got the first table here where it lists the appliance, maximum heat input in kilowatts net, and then I convert that into my meters cubed. And how I do that is we take the kilowatts net and divide it by 10.76, which is the calorific value of natural gas. If we're using a different gas like propane or butane, there'll be a different calorific value. Once I've got that, I then put all the figures in here. And then we can go to the next chart. On the next chart, we start off with sections of pipework. Again, maximum heat input. So when I say maximum heat input, this will be how much gas needs to go through that pipe at that time. Maximum flow rates, estimated pipe lengths in meters, fittings on a estimated pipe size. My brain's going. Estimated pipe size is here. Then we got the actual pipe length. Then we got the fittings. Then we got to work out how much that fittings equals to. So remember before where we said a 15mm elbow, 90 degrees is 0.4, I think, if I remember correctly off the top of my head. So that would go in there if there was one elbow. Then we add the equivalent length and the pipe length together, and it comes out on this total here. So it's a nice simple little chart. So you just work your way along. But unfortunately, this isn't the end of it. Once we've got our lengths, we take it and put it in this table here where we got the lengths. Then we got work out our pressures from the first table. We're going to go into that one from the BS 6891. And once we've got that information, we just multiply our lengths by our pressure loss, and it'll tell us how much gas we have lost over that entire run. It sounds a lot to do, but once you get used to it, like for myself, I've got this set up on Excel where it automatically does all the maths for me. So all you got to do is put the information in, and it's done. Nice and easy. Then once we've got all these pressure losses at the end, we can then work out what the pressure loss is over the entire run, and we can put all this information into this final table. Very clean, very simple, and if you've got it right, you will have less than a 1 millibar drop over an entire run from the meter to the appliance that you require. So let's have a look. So on this example, I have only got one appliance on the system, and we're going to size it to BS 6891. Okay, so remember the first one that we drew where we have a gas meter and we've labelled him A. We've got our pipe run going along to our gas fire where we've labelled it B, and it is a 7 kilowatt net appliance. So first things first, here is that bit that I always like to do. So we put the appliance in here, then we put the 7 kilowatts net in that box there. And then I divide that by 10.76, which gives me a gas rating of 0.65 meters cubed an hour. I like to follow this one on that one. So remember that detail. So 0.65. So first things first, we're going to look at this little table here. As you can see, I've adjusted it. We only need the one line for this because we've only got one section to worry about. So let's have a look-see here. So we've got A to B. Nice and straightforward, and we've got 1, 2, 3, 4 elbows. We've worked out the total length of the pipe, so we've added all this together is 3.2 meters. So we're gathering our information. So as I say, we've got 4 elbows. So we're going to have a look at this. We go to this little table here. I'm going to say that the pipe work is going to be 15 mil in diameter. So already I'm looking at this line here. We're going to use 90-degree elbows, so we can go straight to here, and we're looking at 0.4, which I remembered correctly. Thank God for that. So we take the information, we put in section of pipe, so it's A to B from the meter to the fire. We put in 7 kilowatts for our maximum heat input. We divide that by 10.76, which gives me 0.65. Our estimated pipe size, which I've said already, is going to be 15, so I'm going to guess it's 15. If you're doing this in real life, at this point here, we go from pen to pencil. And this is another reason why I like doing it on the computer, as you can quickly change it. If you do it in pen, you've got to scribble it out, change the sizes. So from then onwards, I usually use a pencil. My pipe length, we've already said, was 3.2 meters. And I've already said that we have 4 elbows. Each elbow is the equivalent of 0.4 meters. So 0.4 times by 4 equals 1.6. So we add the 1.6 to the 3.2, and that gives me 4.8 meters. So that's the equivalent length of that bit of pipework if we strained it out with the elbows in. So we take that information, we put it in this box here. Now, this table here, we're going to now go back to the table that I showed you from BS 6891. So it's this one here. So we've got this table here. We're going to go for this fire at 7 kilowatts or 0.65. So I'll whack that one in there. The closest we've got is 0.75. Now this is why I like to use the 0.65. It's just easier for me. I always go down that first column. And then we've already said that we're going to use a 15mm pipe. So we go along like so. And you can see the bit where it crosses in the middle. 0.0447. That is the answer that we need. So what they're saying is for a metre of pipework, 15mm, you will lose 0.0447 millibars of pressure if you were trying to push 0.75 millibars of gas through it. And millibars? Of meters cubed an hour of gas through it. So we then put that reading in there, and as I say, nice and straightforward. That times by 4.8, that gives me a loss of 0.21 millibars over that entire run in 15mm pipe. So it's good. I like this one. So we take that information, we go A to B, 0.21. Our total loss in the end is 0.21. So is that satisfactory? Is that more or less than 1 millibar? It is less than 1 millibar. So yes, the installation has been designed correctly. Nice, easy, only one appliance. I love one appliance installations where I don't have to do that much thinking about it. I can just go in, work out the pipe lengths, and I know what sizes I'm going to use. But the problem happens when we start putting in more than one appliance. Sorry, having a drink. Now, remember the standard system where we have a gas fire, a boiler, a cooker. We've now got to work this out. We've split it all up into its various categories, so we know where everything is. I've now split my appliances, and I've got 3 lines, so we can put them in. So my gas fire, the gas fire was 6.5 millibars, 6.5 kilowatts net. So all I've got to now do is convert it into meters cubed, so that is 0.6. Then we got the cooker, that was 18 kilowatts net. We changed that into meters cubed an hour, which is 1.62. Then we got the boiler, 32 kilowatts, works out at 2.97 meters cubed an hour. Now we can go to our next table. So we're now going to look at the various sections. So the first section we're going to look at is A to B. Okay, we're going to look at A to B. So let's have a look at the typical system. A to B. So let's have a look. So here is A, there is B. So from A to B, we've got 1, 2, 3 elbows. We don't include this T because we stop at that T. That is where we're going to. Then we also need to know how many appliances are on this length of gas pipe. So in order to supply enough gas to the appliances connected. So at this moment in time, all 3 appliances are connected to A to B. So we're going to have to remember the 6.5, the 32 and the 18 kilowatts net. Our lengths, so we got 2.6 meters of pipe work, 3 elbows and our appliances. So let's start putting the information in. A to B, in. As I say, all 3 appliances are connected, so we add all them up. That gives me a 56.5 kilowatts total requirements on that one length of pipe. We've got to supply enough gas for all 3 appliances on that section of pipe. We change that to meters cubed an hour. So 5.25, brilliant, we're happy with that. Then we're going to estimate our pipe size. Because it's such a large quantity of gas that we're having to pass through, I'm going to say 28 mil. We've worked out that the gas pipe length was 2.6 meters, so I want to put that in there. Just checking the elbows. 1, 2, 3, 3 elbows, no T's, no nothing else on there. So we can put 3 elbows. Now we've got to go back to this table here. We're going to use 28mm pipe, so we use 0.8 as our equivalent length for each elbow. So we're going to use that. So 3 elbows times by 0.8 equals 2.4 meters. So we add the 2.6 and the 2.4 together and we come out with 5 meters. That's the first bit done. Now let's look at B to C. So B to C is here. Oh, sorry, lost my pointer again. B to C. So we've got 1 T. But we need to remember, is it an exiting or an entering T? This one is an exiting T, so because it's got to go along and then up. And we're going to C, so there's only the one appliance. There's no other T's or anything like that. So we'll start putting the info in, B to C. As I say, we've got one appliance on there, so 6.5 kilowatts. Change that into meters cubed an hour, 0.6. On this one, we're going to stick with a straightforward 15mm pipe. We'll put in the length, which was 1 meter. As I say, we've got to remember the T. The T is an entrancing or an exiting T. It's an exiting T. So then we go to our little table here. We're going to be using the largest diameter pipe. I know we're going to 15, but it's connected to 28mm pipe. So we're going to use that length there. Then we're going to be using exiting because it's going to come across and then up. So we've got to add 2.3 meters to that pipe work. So 1 plus 2.3, 3.3. Now we go B to C. In fact, we'll cover them all. We'll do all the rest of them in one go. So we're going to go B to D, D to E, and D to F. I'm not going to go through backwards and forwards through the picture. We'll just remember all this information that's on there and we'll start putting it in. So, B to D, we have only 2 appliances left. So we've already covered the gas fire, so we can take that straight off of there. So it's only going to be 50 kilowatts. So we change the 50 kilowatts into meters cubed an hour. This time, because we've taken the gas fire off, I'm going to drop the pipe sizing down to 22mm. So B to D will be 22mm. It is 1.5 meters in length, and there was no T's, no elbows that are affecting it in any way because it was just a nice straightforward length. So that's going to be 0 all the way along. So the end point is going to be 1.5 meters. D to E, we've got the cooker. And the cooker, again, is a nice straightforward connection. It's only the one appliance. I'm going to change that 18 to meters cubed an hour, so that's 1.6. I'm going to use 15mm pipe because, as I say, it's only the one appliance on there and it's fairly low kilowattage. Okay, 18 is quite high, but it's a fairly low kilowattage, it will be fine. We've got 0.3 meters of pipe work. As I've said, there is no elbows, there's no T's that will affect it, so it's nice and straightforward, 0.3. Now, D to F is going to the boiler, so there's 32 kilowatts there. We change that into meters cubed an hour. And I'm going to guesstimate my pipe work because it's a larger appliance. I'm going to give it 22mm pipe work. It is 1.5 meters in length. It has, this time it has it slightly different. It has an exiting T and elbows. I think it was 2 elbows in total. Yes, it was right. So 1 exiting T and 2 elbows. So we go back to the table again. We look at 22mm elbow and 22mm T, which gives me 3 meters in pipe work. So we add the 3 to 1.5, that gives me 4.5. Right, so now we can take this information and put it into a table. I have added these 2 extra columns here just to refresh the minds so you know where I'm coming from when I go through this one. So the first section, A to B, I said was in 28mm pipe. We've got to get 5.25 meters cubed of gas going through it. The second section was, what was it, B to C. So that was 15mm in pipe, and it only had 0.6 meters cubed of gas to get through it. And then it was B to D, 22mm pipe, 4.65 meters cubed an hour. Then it was D to E, which was just the cooker, so that was 1.6, and then D to F, which was the boiler, 22mm, with the 2.97. So we then go back to our little table here. So we'll go, all appliances are on first section, A to B. Yeah? So we've got to change that into that. So we can whack that down there. As you can see, it's dropped right the way down the bottom. These little lines here means that you cannot use this pipework to pass this much gas through. So we cannot use 15, 12, 10 or 8. It's just not allowed. It never will work. 22 can, as long as it's not too long. 28 and 35, very easy. But our pipework is 28, so we'll whack that little line in there. So we've got to remember 0.0548. So we can put that in there. So we times the 5 by that. That gives me a 0.27. So the next one along is our fire. So that was 0.6. And then we were going to use 15mm pipe. So again, 0.0447. So we can put that in the box. Times the 3.3 gives me 0.15 millibars loss of pressure. Next one, we've got to have 2 appliances on there. So we've got the 4.65. So we'll go to the closest one. We cannot go below that. We can only go above it. So we've got the closest one. And it said it's going to be 22mm pipe. So we put that there. So we've got to remember now 0.1681 and put that in our box. Then we times that all together and it works out at 0.25 millibars loss. Next one is for the cooker. 1.67. We get the closest one, which again is that. The pipe size was going to be 15mm. So we go along there. So we now remember 0.1832. We put that in the box. And then we times them together. And that works out at 0.05 millibar drop. So that one really had no loss whatsoever that you needed to worry about, which was a good thing. So the last one on here is the boiler. Quite the biggest appliance out of all 3. So we find that one there. There's the closest we got, which was 3 meters cubed an hour. We're going to use 22mm pipe, so we wing it along there. And that leaves us with 0.0769. So we put that in that box there. We times the 4.5 and that together, and it gives me 0.35. So we just did the foundations of it all in its place. So now we go to the last part, the important part. This is where we find out if the appliances are going to work. So we go to our little table here. To get to the cooker, to get to the fire, we've got to go A to B and then B to C. So we're going to come from the meter to the first T, then we're going to go from the T to the gas appliance. So let's have a look on here. So this is A to B and this is B to C. So we've got 0.27 and 0.15. So this is the section we need. So we're going to put these in this little table here. So we put 0.27 there and 0.15 there. That's the fire done, because that's all we need to do to get to the fire. So we added them all together and it works out at 0.42 millibars loss. So we put that in that box there. Is that less than 1? Yes, it is. So it's going to be good. So we then go A to B on here again. This is going from the meter to the cooker now. So we've got to go A to B, B to D, and then D to E. So we go and get all the information from all 3 of them. And we put them in the box. So 0.27, 0.25, 0.05. We add them together, and that gives me a grand total of 0.58. Again, we look at it. Is it okay? In my brain, yes, I'm saying yes. Then we go to the boiler. Well, it's got to go A to B, B to D. So we already know the readings on there. Now we've got to go, that should say D to F on there, so I do apologise. The joys, we do make mistakes occasionally. I will fix that one later. So D to E, F. We add them together, 0.87. Little bit close, but technically speaking, it is less than 1. So we already know that one is correct. We already know that one is correct. As that one is left to less than 1, that is okay too. It will work. So it is all less than 1 millibar drop. If, however, you are thinking later on you might add another gas appliance to the property, that one there to the boiler would be something I would be worried about. So I might rejig that around. But as a gas engineer installing the job, if no one told me there was going to be nothing else put in, I'd be more than happy with that, and it would work perfectly fine. But all three appliances would never starve each other, they would work to their peak efficiency, and if you did happen to have the gas fire, the cooker, and the boiler on, which most people have one time of the year, it will not affect any of them. They will work perfectly. So, in summary, you should hopefully now have an understanding of the following areas: the importance of gas pipe sizing, how elbows and T's affect the pipe sizing itself, where we add more meterage, the equivalent length of a meter. Pipe sizing chart found in BS 6891, how to draw them, how to calculate, and you should be all right now to have a go at maybe at your own property. Why not have a go? See if you can work it out. Go through this PowerPoint again. If you are using natural gas, it will work properly. Pause the video on the chart so you can quickly work it all out and see if your gas pipe work at home has been sized correctly by the engineer who installed it. If you have any questions, please feel free, leave them in the comments box. But if you have enjoyed this, please remember, drop a like, leave a comment, and even hit that subscribe button to help support us. So I hope you enjoyed. Hopefully soon there'll be some more videos coming shortly, because I am getting near the end of the year. My students are almost finished. So it is all good. So it should hopefully start to flow with a few more videos. So thank you very much for watching, and I will catch you in the next video. Thank you. Bye bye.